When a car turns left, the right tire travels around a larger circle than the left tire. It has farther to go in the same amount of time, so it must rotate faster. If the driven wheels were locked to one solid shaft, one tire would have to scrub across the road every time the car turned. A differential solves that by accepting one rotating input from the drive shaft and allowing the two axle outputs to rotate at different speeds. In a basic open differential, the ring gear turns a carrier. Small spider gears inside the carrier let one side gear speed up while the other slows down. On dry pavement, this is elegant. The average speed of the two axle shafts follows the carrier, while each tire gets the speed its path requires. The compromise appears when one tire loses traction. An open differential delivers nearly the same torque to both axle shafts, and the maximum useful torque is limited by the side with less grip. Put one tire on ice and one on dry pavement. The icy tire may spin, while the tire with grip receives too little torque to move the vehicle. A clutch-type limited-slip differential resists that speed difference. Clutch packs connect the side gear to the carrier, so some torque can transfer toward the tire with grip. The amount and timing depend on preload, ramp angles, fluid, wear, and whether the unit responds to acceleration or deceleration. A helical limited slip uses geared friction rather than clutch plates. It can feel smooth, but many designs need some resistance at both outputs and may struggle when one wheel is fully unloaded. A locking differential goes further and mechanically connects both axle shafts so they rotate together. That is useful at low speed when a truck is crossing uneven ground and one tire is in the air. On a high-grip corner, the same lock forces tire scrub and can make steering behavior abrupt. That is why selectable lockers have specific operating conditions. Electronic systems add another layer. A vehicle can break the spinning wheel, creating resistance that allows an open differential to send more usable torque to the other side. Performance cars may combine that brake intervention with a mechanical or electronically controlled limited slip unit. The right differential is not simply the one that locks hardest. A road car needs smooth cornering and predictable transitions. A track car needs repeatable torque distribution under heat. An off-road vehicle may need a true lock at walking speed. Start with the two jobs. Allow different wheel speeds in a corner, then manage torque when available grip is unequal. Every differential design is a different compromise between those jobs.